Okay, now the next thing in our notes says there's an exceptional case. Now, by exception, I don't mean that there's ever a time that P of A or B is not equal to P of A plus P of B minus P of A plus B. In fact, that's always true. You can always depend on this formula. But there is a time when a simplified formula will work, and that is whenever the probability that both A and B occur together is 0. Now, if the probability that A and B occur together is 0, we're saying that these events, essentially, they don't overlap. If one happens, the other one doesn't. A simple example of that, which we'll get to computing for in just a minute, would be this. Suppose we're going to roll the die again, and this time we're going to say that the event L is that the roll comes up to be less than 3, so a 1 or a 2. The event M is that the roll comes up to be more than 3, so 4, 5, or 6. What's the probability that either L or M occurs? One thing you might want to notice is this. If we were to draw a Venn diagram for the event less than 3 and more than 3, we wouldn't get those overlapping circles because there are no outcomes that produce a number of dots that are both less than and greater than 3. As a matter of fact, we're less than 3 or greater than 3. It's just excluding the 3, right? That's the only thing that's not in here. So there's nothing in the overlap. Now, we could use our standard sum formula if we wanted to. The probability that either L or M occurs is equal to the probability of L plus the probability of M minus the probability of both L and M. That works here because it always works. But let's go ahead and fill in the numbers. The probability that the roll will be less than 3 is 2 out of 6. The probability that it will be more than 3 is 3 out of 6. And what's the probability that the roll would be simultaneously both less than 3 and greater than 3? Well, that's impossible. L and M don't overlap, so 0 out of 6 of our outcomes give a number of dots that's both less than and more than 6. So this is equal to 5, 6, but the thing you notice is that if we had simply neglected this term, we would have been neglecting a 0, and we would have gotten the same result. Well, the bottom line is this. If A and B cannot happen together, then we say that they're mutually exclusive. And in that one case, if A and B are mutually exclusive, then the probability that either A or B occurs is simply the probability of A plus the probability of B. It would also be true to say it minus the probability of A and B, but mutually exclusive simply means that the probability of A and B occurring together is 0. So if we want to fill in all the blanks on our page, we write just basically what we've done before. The probability A and B is this sum that we were just looking at, except I called it L and M to more easily keep them straight. The Venn diagram looks like this. There are 2 less than 3. There are 3 outcomes more than 3. There's 1, 3. That's in neither one. And this does agree with the calculations that we made. All right, let's move on to the last example on this page. The insurance company we were considering before that was studying their customers has decided to subdivide that group of customers in yet another way. They looked at simply the number of claims over the last 18 months, and they had customers who had 0, 1, 2, and 3 or more claims over the past 18 months. Our job is to compute the probability that a customer selected at random is in one of the extreme classes, either no claims at all or 3 or more claims were made. Well, we notice, first of all, that if a customer makes no claims, then they certainly could not have made at least 3. And if they've made at least 3 claims, they couldn't have made 0. These are mutually exclusive events. So all we have to do is look up the probability of making no claims at all, of making 3 or more claims, and simply add them up. Let's say N for no claims and T for 3 or more claims. We can use the simplified addition rule. 3,000 of the 3,750 customers made no claims. 50 of the 3,750 customers made 3 or more claims. So the probability that a customer made either 0 or 3 or more claims is 3,050 divided by 3,750.